I will show you how to use the Desmos Graphing calculator to help students analyze behavioral functions. So in a browser, go to desmos.com. So let's click on Start Graphing. You can use the graphing calculator without an account, although some functionalities related to organizing and saving your work will be limited. Okay, so I have signed in, and this is visible in the top right hand corner into my account. Clicking on Open Graph, and you can see the list of the graphs that I have done prior to this demo. Go to Add an Item by clicking on the plus, and I can add, just simply state a function. So for example, add an expression. Or it moved me into the line 1, so I can go here and I can write f of x is equal to, let's say, x plus 2 divided by x plus 3. I can also, for example, write g of x is equal to e to the, so let's say e to the x squared, and you can see how the graphs are being plotted at the same time as I'm writing. I can make the graphs visible or not visible just by clicking on the circle on the left hand side, and that makes the graph visible or not visible. I can zoom in and out. I can change the scale by changing the scale for the x-axis. Say for example, I want to just show it from 0 to 2, and y-axis from negative 17 to 500, let's say. So this would be, and you can see how the scale on the axis have changed. I can add arrows if you would like, if I would like on both axes in both directions, or just in the positive direction. I can add axis numbers or remove them. I can have minor grid lines showing and not showing. I can even remove the grid completely. So there are many things that I can do. I can add a label to my axis. I can type in anything that I would like. Let's say x is demand and y is I don't know, profit, let's say. Okay, or something like that. And you can see how it changes right away on the graph as well. If I would like to save this, I can just click on Save button and save the graph. Now there are different ways that I can add information as well. So for example, if I go into a line, I can click on Add Item and I can add a note. So for example, I can say, in this note, this is a demo for using the Desmos Graphing calculator. I can move this note around, say I can put it right up at the top. I can also, for example, add a folder. Okay, and I will, here I will say I will define the functions. Okay, define the functions, and here so these are the two functions that I want to define, and I want them to belong to the folder. So what I will do is I will grab the circle and just drag it up towards the folder until the left line appears. This means that this graph is now within the folder. And I can collapse the visibility of the folder by clicking on the drop down menu. So you see now all the items that are in the folder are not visible, and I can also make them visible as well. I can make the function visible, but then the folder not visible. So anything that is in the folder is now no longer visible. We can also define functions using data, for example, send them to a document and ask them to import this data into Desmos by just simply copy pasting. So if I go into a new field, I can control copy paste into the line, and I get the points plotted right away. There are a number of things that the students can do. They can use regression to model this as a function. And the best way to learn how to do that is to go to the help tool, where we can find a number of tours. For example, how can I build function models through regression? A tour will take you, lead you through steps on how to do that. So there are a number of things that you can have students do in Desmos to analyze behavior of function. They can explore them using static and dynamic means. So for example, we can look at the one-sided limits. We can create a dynamic visual for students of how to visualize the one-sided limits concept. So in this particular case, you can see that we can set in a note what is a task. So for example, f of x, I can define this to be any function that I want. Say I want, for example, x minus, so here I'm going to use a rational function. So x minus 1 over x plus 2. And then I ask the students to set the value where we're going to be evaluating the limit, value of x. And let's say maybe a is 3, okay? And I'm going to zoom the graph so I can see 3 is right here, so this is going to be my a. In fact, actually, you know what? I can even add to plot a point. X is a and y is 0. And here is the point. This is where I'm going evaluating the limit at. And I can actually even label it at 3, 0 right there, or I can choose not to label it. Let's see what happens then if I plot the functions as it approaches the value of a. So this is me writing an instruction to the student of what is about to happen. I'm going to let h to be the difference between the a and the x coordinate as I plot this function. And then I will see what happens as h gets smaller and smaller by clicking on the play button in the next line. So h here will go from -8 to 0. This can change. I can change it by clicking here. I can organize the components of my example in folders. So if you look at this folder is how do we plot the left side function as it approaches the left side limit. And so if the students were to then say press H, they would see that this is what happens to the function as x approaches 3. Okay? So we can then discuss what is the limit of this function as x approaches 3. I can stop the demonstration, I can change it, and I can discuss, for example, well, what will happen, where will things go funny? Well, things will go funny when x is equal to -2, so let's set a to be equal to -2. Let's say I want to see only what happens as I approach it from the left. I'm going to make the right invisible, and let me plot it then, and I'm just looking at from the left side limit. Okay, so as the function approaches -2 from the left, this is what happens. So there are many different ways that you can use the graphing calculator to provide dynamic demonstrations to students about what happens as a behavior, as we investigate the behavior of functions. And finally, very, very useful tool, which is to share the graph. So when you have created your activity, you can share this activity with the students through sharing of a link. So you just share the link with them. Make sure though to note that the link will only show the status of the work, status of the graph at the time when you created the graph, and any subsequent changes will not be reflected in the graph that has been linked through through the sharing. The students likewise can share their results with you as well. So you can ask the students to incorporate the links or even just the images. So if you click on an image, a graph, image of the graph can be then exported into a document, let's say that they have to create for submission as part of an assessment, etc. If you have any questions whatsoever, the help tool and the support that is provided by Desmos is extensive, and don't hesitate to use it.